Hello again. This is 14.2, uses of our freshwater that we just talked about. So uses of freshwater. Freshwater is used for agriculture, industry, and personal activities. So if you look at our diagram here to the right, low and middle income nations, global average, high income nations, between all three diagrams, you kind of see the same sort of pattern that agriculture use up most of our fresh water. So low and middle income nations, 82%, global average is 70, and then high income nations, 59%. So even though you have a difference of income levels, it's still agriculture use as the biggest, industry uses next, and then personal uses are always the smallest fraction. So agriculture, industry, personal uses, these are the major three ways that we use all of our fresh water, agriculture being the biggest. So what we use water for in agriculture is crops and livestock. So that's what we use most of our fresh water for. It takes 400 gallons of water to produce 2.2 pounds of wheat. All right, so 400 gallons of water just to produce 2.2 pounds of wheat. So imagine how much water it takes in order to produce all the wheat across the country. It's a lot more than that, right? 400 gallons is more than what one person drinks in 1 year, and it takes even more water in order to give to all the livestock. So we use a lot of water in order for our crops to grow and in order to give water to all the livestock out there. Uses for industry. American factories use 18 billion gallons of water to make and transport their products. All right, so they use it in the process of making it, and then they also use it in order to help transport these products. Power plants actually use water when they're creating electricity to cool down their machinery when it overheats. So anytime they're making it, so any type of energy usage, which would be coal, oil, natural gas, anytime they're using any of those things, they usually use water to cool it down. So that also uses some water. And then used in the process of making oil and gasoline. So 2.5 gallons of water makes 1 gallon of gasoline, right? And if you ever look at the gas station when you're filling up your car, right, some of you are going to have 13-gallon tanks. The bigger vehicles have 25, right? And that's per time that you fill up at the gas station. So 2.5 gallons for every gallon, right? That's a lot of water being used for oil and gasoline. That's a lot of water being used. All right. Personal use. All right. We kind of talked about this. We talked about a personal well. So if you either have a well at your house or you have, you get it from pipes from a water supply company. And then these are some like average things that you guys might do throughout the day and how much water it takes to do these things, right? So if you have a swimming pool, to fill an average size swimming pool, 72,000 liters or 19,000 gallons of water. To water an average sized lawn, 750 gallons. A 10-minute shower is 40 gallons of water, right? That's why they always say to take shorter showers, because 40 gallons for a 10-minute shower. Flushing the toilet, right? How many times do you do that throughout the day? And then multiply it by the amount of people in your house, right? That's 6 gallons of water. And then anytime you load and run the dishwasher, 6 gallons of water. So we do use quite a bit of water, and there are techniques in order to kind of help conserve water, but that is a lot of water being spent doing our natural daily activities that you probably don't even think about. All right, so when we use our surface water, and remember that surface water is 1% of the fresh water on Earth, we usually use water diversion and dams to try and move water to dry areas. So most of you guys know what dams are. You basically block up the end of a river in order to create like a small reservoir. And it basically helps to conserve water so that we can use it when we need it, rather than not having it available and trying to find water at that point. Water diversion is when you kind of divert the water or change the direction of the water so that it goes to an area where you need it. So anytime you overuse diversions and dams, it can lead to dried up rivers or seas. One famous example of this is the Aral Sea. It was the 4th largest body of fresh water, and now if you were to look at a picture of it, 90% of that is now gone. So it basically the entire lake is dried up, and now there's like small sub lakes that are kind of made off of that. But that's all used in Asia, where they plant cotton. Right, cotton is a plant that takes up a lot of water, so they use a lot of water in order to help it grow. And because of that, they lost the fourth largest body of fresh water. It's no longer there. Groundwater usage. Groundwater is the 20% or 21%. Groundwater is being used primarily for irrigation faster than it can be replenished. So remember, we talked about irrigation and the problems that we have with using too much water, right? It can sog up the crops, help them not to grow, actually. So it's very important that we keep track of when we're spreading that kind of water around, and obviously so that we're not wasting it. Groundwater mining is kind of when they go under the ground and tap the original source in order to get it faster than we are now. And when you do that, we get the water faster, but we're also getting it faster than it can be replaced. So we're not getting more water back when we're taking that water. So yes, you get more water quicker, right? But then you also are going to be out sooner. This causes groundwater to become a non-renewable resource. Like I said, if you can't get the water back through the water cycle, through evaporation and then condensation and then precipitation, if you're taking it faster than it's doing that, then it's now becoming a non-renewable resource, and you really have to be wise when you spend that water. So aquifers are being depleted, causing water tables to drop 1 to 3 meters per year in these areas. All right, another area where they're trying to think about groundwater mining is in Las Vegas, right? That's a very dry area, but Las Vegas has a lot of people in it, and it requires a lot of water in order to support life there. So they're trying to take water from all these different places, and they're dropping the water table, which we saw back in the other slides, right? If you drop that 1 to 3 meters per year, a lot of people's wells are going to dry up. So that's not a good thing either. Sometimes this can even cause land to collapse due to lack of water. There were some pictures from Mexico where the buildings were actually collapsing because you're removing a lot of the water, which is making the ground not as solid, and it drops the land. So all these bad things are happening because you're trying to take the water faster than it's being replaced. So not a very good idea. So what are our solutions at this point? So you can either increase the amount of fresh water that we have on Earth, or decrease the demand for it. Both being difficult, probably decreasing the demand for it more difficult because you have to get a lot of people on the same page in conserving water, which is hard to do. So increasing the amount of fresh water is a short-term solution, but decreasing the demand is more difficult, but absolutely necessary for mankind if we're going to have water available for everybody. So one way that they kind of create more fresh water is the process of desalination. All right, and what they do is they make more fresh water by removing the salt from salt water. All right, so they kind of do this in two different ways. You can either evaporate salt water, or you can either put the seawater through a filter. When you evaporate the salt water, obviously the water is being put into the gas form in water vapor. The salt is being left behind, and then they condense the water and then bring it back into the liquid form, and it's pure fresh water. However, it leaves behind that salt waste. So it's good, we can make the fresh water, but now we have salt waste and we don't really know what to do with it at this point. And then the filter, they usually just push it through a filter. The filter catches the salt, making fresh water and salt water. But again, you get that salt water waste, and we're not sure how to use that or what we can use that for at this point. So it also is expensive. It requires a lot of energy to do it. And like I said, it leaves us with that salty waste that we don't really know what to do with. So good idea, not a long-term solution though. Some solutions in these three areas that we've seen us spending water in order to kind of conserve it. So in agriculture, they use drip irrigation to remove wasted water. So they basically have these long pipes and it just drips the water on the plant. so it prevents a lot of the water from being evaporated before it's used. Gets a lot of that wasted water out of there. And using climate appropriate crops is super important. Using crops that are suitable to the area, right? If you're growing a crop that needs a lot of water in a dry area, right? How much water are you going to have to spend trying to help that plant get enough water when you can just use a plant that, is used to those conditions and can live off the land, and you don't need to water a whole lot extra, right? That's important. Industry, recycling wastewater is important, rather than just using it once and getting rid of it. Reusing that multiple times before you get rid of it is important. Finding other ways to cool machines, so finding other cooling techniques rather than using water would be a good idea too. And for our personal homes, watering properly at night, that also prevents evaporation because the sun isn't evaporating the water before it gets into the plant. Or choosing appropriate plants for your area as well. Same thing as the agriculture. Picking crops that are appropriate and can live off the land without extra water. And then low flow toilets and appliances. So these appliances don't use as much water every time you flush. So that saves a little bit of water every single time that you flush. And in case you're skeptical that these are not going to help that much, between the year of 1980 and 1995, we decreased water consumption by 10%, right, which is good. But during that time period, the population increased by 16%. So you probably saved a lot more water based on the population size percentage. So it is possible, but everybody has to participate in order to do this, in order to help conserve water. So it's just something to think about as you're going throughout your day. We've talked about the availability of food, right? But we have kind of the same problem with the availability of water because we're using a lot of the fresh water, and then also the ice caps are melting into the salty ocean. So that, that's also going to be a major problem when you're thinking about the availability of fresh water. All right. So that's all I have for you. Thanks for listening.